Hello everyone, today we're going to be looking at mass spectroscopy. We're going to look at the basics, how to get the graph, and then how to analyze it. There are 5 steps you need to know for IB. Vaporization is the first one, getting your sample from a solid or liquid state to a gaseous state. Then your sample enters this chamber where it is ionized. A beam of high energy electrons is shot at your sample and knocks out some electrons from your sample because of the repulsion. Now, let's focus on having one electron knockout, which means your sample gains a positive 1 charge. Now that it's positively charged, we can accelerate it. In this diagram, it's very small, but we can see 2 plates. One of them is negatively charged and one is positively charged. Because it is negatively charged, it attracts your ion to move forward. So it accelerates it. Okay, through this path. Then it reaches an area where we have applied a magnetic field, and this causes your ion to deflect, so to change its path. How much it deflects depends on 2 things, its mass and its charge. And that's where we're going to see later on the mass to charge ratio. Okay, now we're going to move a little bit into physics, but the heavier an object is, the higher its mass, you will require a higher force to actually cause it to accelerate. So something which has a high mass is not going to deflect as much. On the other hand, if you have a high charge, then it will be more influenced by the magnetic field. And there you need to look at physics and Fleming's law if you want in more detail. Now, we can see this green path in the middle. These ions are deflected just the right amount that they can pass through and hit our detector. That is the last stage, detection. Because your sample is charged, it will create a current when it hits the detector. More details on that you can search online. Now, this creates a count, counting how many times you get a certain mass to charge ratio. And this will form our graph, which will look like this. So on the x-axis, we've got the mass to charge ratio. So it depends how heavy your sample is in grams per mole, the molar mass, and the charge, which now we're going to focus on +1 ions, and relative intensity. The higher the peak, the more times that's mass to charge ratio was detected. Okay, so join and watch part 2 to see how we can analyze these graphs. Thank you very much.